27th International Master's Course in Theoretical and Practical Application of the Finite Element Method and CAE Simulation. My name is Juan José Benito. I am a professor at this university, la Universidad Nacional de Educación a Distancia, UNED, UNED, and I am also the director of this master course. As I am largely responsible of this master degree course, and to a certain extent the main host of this inaugural session, I will begin the speeches by welcoming especially our new students. I would like also to welcome the students who continue their studies with us, our teachers, administrative staff, as well as our global and local partners. As every year in this session, I would like to briefly explain the structure and the content of the course. Then we have always been of the opinion that any professional should have totally assimilated the theoretical basis of their subject and be ideally trained in the use of the best tools to carry out their work. This notion, which from the beginning has caused us to look for a balance between the theory and practice, is evident in the title of our course and can be observed in the structure of each module with three evenly balanced parts: fundamentals, application, and practice, and the course material, which include theoretical texts with, which have been specially produced for this purpose, and the best professional software on the market. Furthermore, the growing demand for specialization is clear, and this is addressed in the global structure of our course, with a basic module and several specialization modules. The basic module, which includes theoretical and practical fundamentals, and whose purpose is to bring people's knowledge up to the same level, and is therefore compulsory. This will aid further development at more advanced levels. This module has, this basic module, has 30 credits, and it must be fully completed to obtain the master's degree. This has been drawback for some students who have not been able to do the required work due to their professional duties. For this reason, we have decided to distribute its content over several modules called MD. This can also be useful for people interested in the study of only some of the subjects of the basic module. During the second part of the course, we will have the specialization or expertise modules, which involve in-depth analysis of different areas using theoretical and practical knowledge. I would like to speak about the beginning of the course before finishing my comments about its nature, because they partially explain its structure. I remember how in 1992, Miguel Ángel Moreno, the director of Int'l at that time, and I had the idea of putting together a course on the finite element method as part of our university summer course program in Ávila. This was the initial spark that became our master course. We repeated the experience, and after further courses in Int'l, we decided to organize a postgraduate course based on the ideas while making use of the distant learning methodology of our university. The first course got off the ground in 1994 and was a success, given that a sizable section of our students were professionals in work. The distant learning format was ideal. Moreover, the balance between the theory and practice with a commercial code like ANSYS resulted novel and attractive. Since then, new modules have been incorporated. The first three morphed into 5 the first years, and today we currently have 15 modules and new commercial codes for carry out practical exercises. The distant learning models eliminate geographical barriers, and it has also allowed the last year to be carried out normally despite the pandemic. It only remains to say to our students that we hope the course fulfills your expectations and you find it useful. I also hope and wish that the pandemic does not affect the people who participate in the master, and that it can be conducted normally. And finally, I would like to welcome you once again. Thank you very much for your attention.
Hello, I'm Ronald Siat. I will be assisting you through these masters, along with another staff, of course. For this 27th edition, you might have already access to your corresponding modules. If you have any issues, please contact us. So there might be some problems in the access. You will have different subjects, and you can get all the material and software if it's the case, how to install it in your MV5 software application subject. It can be ANSYS, it can be CivilFem or Patron. So for any of your cases, you have an installation process. You have all the material for study, and each tutor will give you some dates for deliveries. You will perform your deliveries, and you have a schedule, and you can perform all these exercises and then deliver them through the virtual classroom. Of course, we encourage you to use the forums, so it will be easier for all of us and to share all your questions, so everybody can participate. Of course, we have as well our email, or we can set up meetings as well. So please contact with each tutor, which will be very always helping you in anything. So the basic modules are starting now, and in May the master final project and specialized modules will start, but some time before you will have access to get the materials and to install the software. So, well, good luck. As you know, for this 27th edition, inaugural session, we will present as well the price of the last edition, for the 26th edition, and the price for the master's final project goes to Alejandro Cívicos, who has performed a desktop application for structural analysis using Python language and the Tkinter module. So this student has a short presentation to show you his project.
Several master subjects offered me the possibility to know how to code BASIC. First in Visual Basic and then in Python. The goal of this final master project is to go further and make a software who can calculate any structure in 2 dimensions using the matrix method explained during the master. The language code that I use in my final project is Python, and that is for several reasons. Reason number one, Python is an open source general purpose scripting language. Reason number two, Python is a high-level language, sample, and very beginner-friendly. Reason number three is a very good for quick programming. And reason number four, Python has a big amount of libraries available to be used in used scripts, including linear algebra, big data analysis, numerical analysis, artificial intelligence, etc. I choose a module called Tkinter to make graphical interface in the program. As you can see at the moment, this is the main window of the program. I create a well-structured drop-down menu designed to make the program friendly. For example, clicking in geometry menu offers you the possibility to create point or delete geometry, create line, etc. In model menu, you can introduce the value of generic cross-section or add cross-section from library, for instance, IPN, UPN profiles. The load menu allows you to introduce thermal load or gravitational load. This can be punctual, uniform, triangular, etc. In the menu boundary condition, the user can introduce constraint of displacement or constraint of rotation in X, Y, or Z axis. The menu use the linear equation generated with the application of matrix method in order to solve the structure. The user can use also the Cholesky method, who is more powerful in some cases. And for the post-processing menu, we can select the bar result, we can see the bar result, the deformed model, and the total moment, the isostatical moment, the peristatical moment diagram. Now we are going to make a demonstration of how the program works with a simple exercise. We are going to create only 3 points. Number of point of the structure 3 points. We're going to introduce 3 points. The coordinate of the first point is 0, 0. The coordinate of the second point is 10, 0. And the coordinate of the third point is 20, 0. And now we're going to draw in canvas. As you can see, in the canvas, the 3 points have been created. Now we can move them with the mouse or with the central button of the mouse. We can zoom in, zoom out. We can do it also with the button here located in the level frame. For example, zoom in, zoom out, center in, center out, move up, down, left, right. We can do it. The next thing we have to create is the lines who links the point. Geometry lines, and the first line goes from initial point 0 to final point 1, and the second line goes to the initial point 1 to the final point 2. And as you can see in the canvas, the line has been created with heat orientation, very important, with heat orientation in local axis. We can create an additional grid with the number of division and the color of the grid. For instance, we can create 20 division and the color gray, for example. But for me, that is not useful. It's not very interesting. For that reason, we are going to deactivate this grid. Okay. Once we have created the lines, we have to give them the material and the cross section. For that reason, we are going to go to the model menu. We have two different ways to introduce the material and the cross section: generic cross section or picking a cross section from library. A cross section from library is very easy. Here we have to select one of the two var we have create. We have to select the material, the type of profile, size. We have every single profile. We have to introduce the length and the connection of the bar. But we are not going to do it that way. We are going to select the another way. Generate cross section. We select the first bar of the structure, the bar number 0. We introduce the job module. We introduce the inertia. We introduce cross area, and we introduce the length bar, and also the connection type of the bar. We have once we have to introduce all data, we can calculate the bar local matrix in local axis for the first bar, and for the second bar we are going to introduce the same data, so we can calculate the bar in the matrix bar in local axis, and then we can calculate the global matrix of the structure. The next step is to introduce the load. We are going to the load menu, and we are going to introduce gravitational load. Gravitational load, we are going to introduce uniform load in the two bars. For the bar number 0, we're going to introduce a value of the uniform load 10 kilonewtons in the negative y-axis, and for the second bar the same thing. And now to complete our structure, we have to introduce the boundary condition. The boundary condition, we are going to introduce, we have 3 nodes. For the 3 nodes, we are going to introduce the simplest, the easiest, fixed support. That's this type. So we're going to introduce for the 0, for the 1, for the 2. Now we have to solve the problem with Cholesky and matrix method. We are going to introduce matrix method because it's very simple. And now we are going to see the moment diagram, the total moments. We can do total moment. We can see the isostatic moments. We can see the peristatic moment. We can see a lot of things. But we are going to, the last thing we're going to do in this presentation, we are going to calculate quickly, faster, another simple we're going to calculate a structure a little more complex. I'm going to do it faster, only to show you. We're going to the lines 0, 1, 1, 2, 2, 3. Now we're going to select the cross section. Rigid, calculate for the first bar, for the second bar, and calculate the local matrix. Now we're going to create the loads, uniform loads in the bar, in the second bar, in the central bar, 10, and the negative y-axis. And then we have to calculate the boundary condition, in this case, clamp for the 0 and the third node, and for the rest, free move. Okay, and now we're going to solve with matrix method because it's a little structure, and then we're going to calculate the total moments. We're going to show the isostatic moments. We're going to calculate the hyperstatic moments and the total moments. So that's a little bit my final project. Thank you very much for your attention. Thank you very much.
Well, after this presentation, we have another one showing a real case study of what will you gonna perform using the finite element simulations. In this case, applications for water tanks using CFD analysis. Rubén Establés, who is a civil engineer in the research and development department of TOP-CAE, will give you the presentation.
Hello everybody, and welcome to this opening lesson of the 27th edition of this International Masters in Theoretical and Practical Application of Finite Element Method and CAE Simulation. First of all, I would like to thank the director and coordinator of the master for giving me the opportunity to present you this case study called Computer-Aided Engineering Applications for Water Tanks. Also, I want to send you all of my best regards and encourage you to enjoy with this master, especially in these difficult moments that we are living due to the COVID-19 virus disease. Let me introduce myself. My name is Rubén Establés. I am a civil engineering, both bachelor's and master's degree. I have worked in aerospace, industrial, and civil engineering fields, and in all of them using finite element method and CFD simulation. Also, I am a fan lecturer of dynamic and thermal analysis subjects of mechanical branch with Patron and MSc Nastran. Actually, I am working as research and development engineering in TOP-CAE department, which belongs to Innovation and Safety Company. I have divided my presentation into 6 main parts: case study objectives, pre-process, which cover topics like inlet and outlet system, scale model, internal brick walls, fluid domains, geometry and mesh, and simulation hypotheses. Another part are analysis, results, proposals for improvement, and finally, to sum up, some summary and conclusions. So let's get started with this topic. First, I would like to talk about the objective of the case study, which is to evaluate the behavior of drinking water in a water tank using CFD simulation. Remember that the meaning of CFD is computer fluid dynamics. The input that we have to start was taken from drawings, photos, on-site visits, and in this case, data from laboratory which studied the hydraulic behavior using a scale model. The water tank has one rectangular chamber with the following main characteristics: dimension with a length of 400 meters, width equal to 180 meters, and a height equal to 6 meters. An inlet system with a special configuration to reduce the water load when it enters into the tank through the pipes. 2 inlets and 2 outlets, concrete pipes, each with a diameter of 2.2 meters and hydrodynamics profile columns around them. Internal circular columns, and 3 internal and semicircular brick walls with holes at intersection with circular columns. It is important to know that these 3 walls have straight walls at the end. The main part of water tank are highlighted in this image. These are inlet system and outlet system, and to complete it, 3 internal brick walls. Look at the inlet system with hydrodynamics profile columns, a passage with a vertical drilled wall, the entrance ramp, and the concrete pipes. This slide shows some image of the real water tank and the geometric model made with the help of design model software. Next slide shows real and model images of the outlet system, and here you can see that the outlet pipes and the hydrodynamics profile columns are around them. As I told you before, during the designing phase, a scale model was made and it used to study the real hydraulic behavior of the flow. In these figures, you can see the civil engineering working with this scale model. 3 internal and semicircular brick walls are inside the water tank and divided it into 4 main parts. Remember that these walls have straight walls in its last spans. Due to its external configuration, the model is divided into 7 fluid domains that work together like one body. They are connected at the areas indicated by arrows in the below images. The transition between the geometric model and the fluid domain is shown here, and we have to follow 3 main steps: from CAD model, extract the exterior volume, and finally to achieve the fluid domain that we use in the fluid software. Here you have a detail of the million of elements that have the model, and in this case, the mesh represent the flow with the water properties. To finish with the pre-processed part, I would like to talk about some simulation hypotheses. It is a steady state analysis. The mass conservation law is fulfilled. Flow in is equal to flow out. It is important to define the mesh continuity between fluid domains, as you can see in 3 images. And finally, I give you some main data. For example, water level is equal to 6 meters. Flow in is equal to 1.4 cubic meters per second. The flow out is equal to 5.1 cubic meters per second. The volume is equal to 418,000 cubic meters. And finally, we achieve a renovation times equal to 64,000 seconds. Now let's move on to the next topic, which is analysis. The tools that are used to complete it can be divided into software and hardware. The software, in which it is used design modeler to define the geometry and mesh, this is the pre-process step, and ANSYS TFX to do the analysis and post-process. the hardware is a Windows server, very powerful and robust, because the analysis time takes you 5 days and the size of the result file is equal or more than 10 gigabytes. So that's covered everything I want to say about the preprocess, and I'm going to focus on results. As you know, one of the most important steps of any analysis is to post-process the results obtained in order to get some conclusions. Here is shown the streamlines with a maximum value of velocity equal to 5 centimeters per second, and it is possible to confirm that the inlet system does not regulate the flow. So the hydraulic behavior is subjected to two main flows, one along the perimeter, highlighted with the horizontal square, and another directed to the first brick wall, highlighted with the vertical square. Some images with the streamline born from inlet 1 and inlet 2 are shown in this slice. The streamline which born from inlet 1 is highlighted in green color, and in the same way, the streamline that born from the inlet 2 is highlighted in purple color. A circuit between the inlet and outlet is created because the internal walls do not cover the entire width of the water tank, as it is shown in this image, where it is represent the streamlines that born from two inlets with a limitation of 25 minutes. Velocity vectors with a maximum of 1 meters per second are represented in this image, and the flow, you can see here that the flow goes through the hydrodynamics profile with the highest velocity. In the same way, a plane with counter velocity is represented with a maximum velocity value of 2 centimeters per second in order to evaluate the impact of the brick walls on the flow behavior. From here, the following 9 slides show the results related to velocity isosurfaces with difference value of velocity from 1 meters per second to 2.5 millimeters per second. It is really important to evaluate them because the velocity isosurfaces represent the volume which has the same velocity value independently of its direction, providing us where is the highest amount of lowest flow velocity. Let me expand on this topic. We have to take into account that the correct behavior of a water tank has to avoid areas with low velocity in condition of water recirculation, because these areas usually gather sediments, break the uniformity of water treatment, and reduce the water quality, and finally produce dead zones into the water tank. Now let's turn on to a new topic covered in this presentation. It calls proposal for improvements. The principal proposals are to add a vertical wall at the upper part of the entrance ramp, and the other one is to extend the circular brick walls to cover the whole width of the water tank. By this way, lateral pass was closed. A new fluid domain configuration is defined with continuous divided into 7 fluid domains that work together like one body. The following 2 slides clearly show the improvement of flow behavior and represent the streamlines with a maximum velocity value of 5 centimeters per second and the plane with counter velocity with maximum velocity value equal to 2 centimeters per second. This graph clearly shows that if proposals for improvements are implemented in the model, it will achieve more volume of water with higher velocity. Remember that this is the main goal that we follow on this kind of analysis for water tanks. Finally, to sum up, I'm going to explain you the most important conclusions that we get from this couple of analyses. This relates to what I was saying earlier. take into account the results from the current operation situation, this is simulation number 1, it is possible to conclude that the inlet system does not regulate the flow, so the hydraulic behavior is subjected to 2 main flows, one along the perimeter and another directed to the first brick walls. A circuit between the inlet and outlet is created because the internal walls do not cover the entire width of the water tank. And the correct behavior of a water tank has to avoid areas with low velocity, because these areas usually gather sediments, break the uniformity of water treatment, reduce the water quality, and produce dead zones into the water tank. So from the proposals for improvement simulation number 2, it is possible to conclude that there is a huge amount of volume with a middle range of velocity that improves the behavior of the water in the water tank. Nothing else from my side. Thanks for your attention, and please don't hesitate to contact with me for any kind of clarification.
So, thank you very much for attending. This is the end of the session. Of course, we will get in touch very, very soon.